is magical. Answering question 22. You got small ball thrown horizontally with a speed of 4 meters per second. So ball U is equal to 4 meters per second. It falls through a vertical height of 1.96 meters, so it's going to fall 1.96. But do remember, it has horizontal velocity here, means that it's not going to fall only vertically, but it's going to also fall or move in a parabolic motion. Before bouncing off a horizontal plate, as illustrated diagram, so diagram is given, area is negligible, means we can use the UV set line. So the diagram is given like this. You have a plate, after that it rebounds. Then you got 0.96 here, and you got 0.98 meters. For the ball, as it hits the horizontal plate, state the magnitude of the horizontal component of its velocity. So, 1 mark, A1. At the plate, it wants the horizontal velocity. 3 mark, you already know, we have done a question like this. When it comes to horizontal velocity does not change. Why? Because gravity is acting 90 degrees to it, that means no effect. Okay? Do you remember? Gravitational pull is in this direction. Therefore, all your horizontal velocities will all be the same. That means in this case, it's just going to be 4 meters per second. Okay, just double check that and see that we're on the right track. 2. Show that the vertical component of velocity is 6.2 meters. So, vertical component at the plate is equal to 6.2 meters per second. As I always say, we like short questions. Why? Short questions we're going to answer already, so it's quite easy to check whether we're doing the right thing or not. So, let's begin. Vertical, we want our UV set line, UV as a T. U here, remember, it's only moving horizontally. There is no vertical component. That means this is equal to 0 meters per second. Here, S is equal to 1.96 meters. A, take our direction positive to be downwards. Remember, you must always show your directions, okay? So plus G, we got 3 variables, that means we don't need to find this. We can immediately find our VB vertical at the plate. So, U as A and V, fifth equation of motion. V squared equal to U squared plus 2NS. 0, V is equal to root 2 times 9.81 times 1.96 meters. I'll give you a few seconds to calculate that or double check the answer for you. Oh, wait a minute, there's no need for us to double check. Oh, why? This is the answer we're supposed to get, so if you do get that value, well done. So my students will ask me a question, check if I write 3 certain figures, is that alright? Yeah, it's fine, as long as you can round off back to square 2. Well done. Okay, I'm going to turn the page on my paper and see whether we have a next question or not. Yes, we do. We have a next question. B. The components of velocity in A are both vectors. Complete figure 22.2 to draw a vector diagram to scale to determine the velocity of the ball as it hits the horizontal plate. So, we need to determine the velocity of the ball as it hits the horizontal plate. So here we need a vector diagram. What that means is they want a resultant velocity. You might ask, what do you mean by resultant velocity? Easy. When the ball falls here, is the velocity vertical or horizontal? It's neither. It's actually the resultant velocity. Why do we have to resolve it vertically and horizontally? So that for us it's easier to calculate. When it comes to physics, there's a lot of things which complicate. So what we do, we break it down into simple parts to make it solvable. Okay? So now they're asking in real terms, how away is the resultant velocity? So quite easy, we got 4 position here. This is 4 meters per second. From your U here, we join this to scale. So this one is 4 centimeters. Then we got 6.2 meters per second vertical. This one is actually going down. So 6.2 meters per second. Also 6.0 centimeters. Oh, apologies, 6.2 centimeters. Our resultant will be here. Okay? So you need to measure this and then find out what the resultant velocity is. Represent. So you can pause the video now, do the diagram, and then check it, and then when you come back, I'll tell you the range of where it's supposed to be. In this case, 7.2 to 7.6 meters per second. That means we use a ruler. Remember, we are doing this scale diagram where we have 1 centimeter is to 1 Newton. So you have around 7.2 to 7.6 centimeters. A famous question, they usually ask about the angle as well. So use your protractor and find out what your theta is. This is, they always ask for the inclination from the horizontal, okay? Rarely from the vertical. Why? Because if you're doing some survey in real life engineering works, it's easier to measure angles from the surface of Earth. Okay? So you can pause this video and then make measurements, and then when I pause it, you will have an angle around this. Theta is 31 degrees to 35 degrees. Now, this is a long question, so let's check out what is the next part. C. After bouncing on the plate, the ball rises to a vertical height of 0.98 meters. Okay, it's shown here. 1. Calculate the vertical component of the velocity of the ball as it leaves the plate. So now, C1, they want to know what is the vertical velocity when it rebounds. Again, if this is negligible, we can use a UV set line. So let's draw a UV set line. UV set. U here, we need to find. V, remember, this is when it's at maximum height. That means your V here will be equal your vertical velocity. So VV equal to 0, direction upwards to be positive. That means A equal to minus G, S is equal to 0.98 meters. We don't need T. Okay? So, VSA U, only one equation, fifth equation of motion. So let's go straight to it. V squared equal to U squared plus 2NS. Then V here is equal to 0. So what you get will be U squared equal to minus 2NS. U is equal to square root of minus 2 minus, but direction is correct. So your G here will be minus 9.81. Negative is destroyed, so it means you have a real number appearing and 0.9 meters. Okay, then pause the video, calculate it. Once you get back, I will show you roughly where the answer is. So you should get around 4.4 meters per second. Okay. Now we go to the last component, C2. The ball of mass 34 grams. So the mass of the ball is 34 grams. Remember again, we're trying a ball here. Okay, so this is your ball. It is 34 grams. So let's say roughly a tennis ball. When you see measurements like this, don't just treat it as a number, because they can ask you estimates. Remember the question? They ask you, what's the mass of tennis ball? You already can see there, around 34 grams. So remember this small thing is because the values that you see are actually real life values. It is in contact with the plate for a time of 0.12 seconds. In contact, 0.12 seconds. Use your answer in C1, which is this one, the velocities, and the data in A2. Data in A2, which is this velocity. To calculate for the ball as bounces on the plate, the magnitude of the average force exerted by the plate on the ball due to this momentum change. Okay, a very famous question. If you have a plate here, if the ball bounces back, does the plate actually feel the force? Hard to imagine? Easy. If you put your hand here and the ball were to hit your hand and bounce back, would you feel a force or not? And most will say, yes, of course I feel a force. If you can feel a force means you can actually calculate it. So let's go to Newton's second law. Horizontal force equal to delta momentum over delta t equal to m delta v over delta t. Mass is 34 grams, but remember, force is in newtons. Newtons requires everything to be in the SI base units. SI base units of mass is not grams, it's kilograms. So 34 times 10 to the minus 3. Your velocity in this case, you have to choose direction. So let me draw a nice picture here of rebound. It hits here and then bounce back. When it hits here, what is our velocity? 6.2. So u equal to 6.2 meters per second. When it rebounds back, what is it actually? We measure here is 4.4. Again, remember this is during rebound. Everything happens here, okay? Not here, not here. All happens when it's in contact with the plate. You feel a force. When you feel a force means something must be transferred to your hand to feel the force. And this is the change in momentum. Key here, force is a vector. You need to choose a direction. So what we should do, we choose our positive to be the final direction. Okay? So delta V, what does it mean? Is mv minus u over delta t. What is V here? V is 4.4. Positive minus u 6.2, but in the opposite direction. So this is minus 6.2 divided by time 0.12. Very frequent question. So understand the concept. I'll give you a few seconds to click. Once you get an answer, feel free to cross-check with me. In this case, I'm going to double-check the answer for you. You should get around 3 newtons. Okay, so again, thanks to my fans, aka my students. Every time, remember, when I do these calculations, I do not calculator. Thanks for sending me feedback to tell me, hey, sure, I think the value is different from the value you show on the board. Thank you for that. And if you manage to find a correct answer, feel free to send feedback to me, okay? So thank you to those students for helping me to calculate and feeding back to me. I hope you will enjoy this video. Complicated, but replay a few times, and you can do it as well.